Okay guys, so just a few questions that I'll help you through here. This was page 120, question 6, 7, 8, 9, 10 and 11. Okay, so question 6 I'll start off with. Just before I do that though, just focus on this for a second, okay? Just to remind you. So, if I have a function that allows me to get the height, the distance, the displacement, or often the cost of something, okay? Well, if I differentiate that function, it will get me a function that will give me the speed, the rate of change, or the velocity of the same thing, I guess. And if I differentiate that function again, it'll get the acceleration, okay, of that thing. Likewise, when we go on to the next chapter, if I have an acceleration function and I want to get back to this, I do a thing called integration. And likewise, if I have a speed, rate of change, or velocity function, if I integrate, I get back to this. Okay, so with that knowledge, let's get cracking into this question. Right, so the question says, the expected asset in euros of a proposed new company will be given by this function. Okay, so the worth of something they buy, or the worth of something they own, will be given by that function, which is 200,000 plus 600t squared minus 200 over 3t cubed, where t is the number of months after the business was set up. So they have an asset and it's either going to increase in value or decrease in value based on how old it is. So the first thing we have to do then is find the rate of growth. So remember, this is a function for cost. Okay, so if we remember back to what I looked at the first one down here, remember the 3 boxes? Cost was in here, and I want to find the rate of growth, so I'll have to differentiate once to get a rate of growth function. Alright? So, if we differentiate this once, we will get 200,000 differentiated to 0. So, well, first of all, it's dm dt equals 600 multiplied by 2 is 1,200 t minus 200 over 3 t squared, and remember we had the t in front here, sorry, the 3 in front, so that will give us, well, 3 here and 3 here can cancel each other out, so it's just 200 t squared. Okay, and they want to find the rate of growth at t months. So when they say at t months, they don't give us a number, we just leave t in there. So there's our function for rate of growth in terms of t. Next one, they want to find out the rate of growth when after 3 months. So we'll sub 3 in to both these. And if you do that, you get 1,800 euros per month. Alright. Third bit. Will the rate of growth be 0 at any time? Okay. So will the rate of growth be 0? Well, let's check. We take our function, which was 1,200t minus 200t squared, and we let it equal 0. We could do a bit of trial and error. We could sub values in for t and see will it ever equal 0, but that's we could be at it forever. So we'll do a bit of algebra, and we will get, let me think now, we'll factorise out actually. So I can factorise out 200t. So 200t multiplied by 6 will give me 1,200t, and then minus t will give me minus 200t squared. That equals 0. Let both of them equal 0 then, so 200t t equals 0, and also 6 minus t equals 0. So t then equals minus 200 and t equals 6. Actually, sorry, that's right. That's not right. I hope you saw where I went wrong there. 200t equals 0. The 200 is multiplying the t, so I can't just bring the 200 across and make it a minus. I have to divide both sides by 200. So 200t divided by 200 is t, and 0 divided by 200 is 0. Okay, so now it's right. So, will the rate of growth be 0 at any time? Yes, when t is 0 and when t is 6. Okay, if I put 0 in or 6 in for t here and here, I get back out 0. Alright, so that's that question done. Right, question 7. The distance in meters travelled by an object in t seconds is given by the formula this. Now it says s there, okay, but don't let that confuse you with speed. It's not, because look, it says the distance, so this is a distance formula. And we're looking for the speed after 4 seconds. So we have the distance formula, we need to differentiate it once to get the speed formula. If we differentiate this, we will get ds dt equals 3t squared minus 4t plus 3. And we want to find it out and the speed after 4 seconds. So we put 4 in for t's, and we will get 35 meters per second when we do that. So that's done. And then we want to find out the acceleration after 4 seconds. Okay, well, we had ds dt, which was the speed function, and that was 3t squared minus 4t plus 3. And we're trying to get an acceleration function, so we have to differentiate it again. So we get 6t minus 4 when we differentiate all this again. And that would be called ds squared over d squared t squared. Okay. Sorry, d squared, that's the squared as before the s. It doesn't really matter. Okay, I'll just write it better here. D squared s over d squared t squared. Hey, you're not going to lose marks for that though. Right, we differentiated again, we got an acceleration function. They want to find out what the acceleration is after 4 seconds. We put 4 in for t, and we will get 20. Okay. And how to show acceleration is meters per second. Okay, meters per second is speed, but if we put a squared here, that'll show its acceleration. Okay, so that's that done. Okay, question 8. A body moves in a straight line so that the distance in s meters travelled after t seconds is given by the formula there. Again, it's distance. So find the speed of the object after 3 seconds. So again, we differentiate that formula. We sub in 3 then for t. So differentiated, we get ds dt equals 3t squared minus 8t plus 4. Throw in 3 then for t. And when we put 3 in for t, we get 7 meters per second. Okay, so if we put 3 in for t there and in there, multiply that, we get 7 meters per second. Right, and that's that done. Find the acceleration after 1 second. So we have the speed function, and we need to find the acceleration function. Finding the acceleration function, d squared s over d squared t squared equals, and differentiate it again. So 6t minus 8. We want to find it after 1 second. So we'll put in 1 for t. We put in 1 for t here, we get minus 2 meters per second squared. Alright, so that's that done. And the last one then. After how many seconds is the body momentarily at rest? momentarily at rest. So what I mean by that, let's have a think now. Let's just look at this. The body moves in a straight line, okay? We know that. So let's just think. Let's say here's the body where it starts and it moves in a straight line, so maybe it shoots up and then after so long it goes back down again to the ground. But at a particular point up here, it stops. It stops in midair for a second. Alright? And what they're asking is, after how many seconds is the body momentarily at rest? So after how many seconds does it take for it to get to this point here? And also, this point could be called a maximum point. Alright, so it's just another way of getting a maximum value. When we're talking about maximum, we differentiate, which we've done already here. We let it equal 0 and we solve. Okay, so I'll take my function 3t squared minus 8t plus 4. Let it equal 0. Factorize that out if you want, or use your minus b formula, or use your guide method. When you do that, you'll get t equals 2/3 and also t equals 2. Okay, so it'll be t equals 2/3 seconds and t equals 2 seconds. Just to make sense of that, because we have two answers here, we have 2 seconds and 2/3 seconds. Well, I would think what's happening is the whatever the object is going up, and it's hitting the maximum point at 2/3 seconds, and then it's dropping back down, and it's stopping again here, obviously, at 2 seconds. Hence, there's one value, and there's the other value. If you wanted to verify that, actually, if you wanted to verify that this 2 seconds, not that we're asked, but if you wanted to verify that that 2 seconds is down here at the place where it started in the first place. If we took that 2 and we put it into this formula gives us the distance the object is from the starting point. If we put the 2 in there, do you know what our answer will probably be? You can check it out, but our answer should be 0, which means after 2 seconds the object is back down to the place it started at, okay? Which is 0 meters away from the origin. So after 2 seconds the object is 0 meters away from where it started. Why? Because it's after dropping back down. Okay, but we weren't asked that. What we were asked was after how many seconds, after what times is the object momentarily stopped? Well, at 2/3 seconds and at 2 seconds. Okay. Right, question 9. An object is projected upwards and its height in meters above its point is projected after 2 seconds, which is this. So this is a height formula we're given. Alright. So, just like the last one really, there's probably an object, it starts here, it goes up, at a certain point it comes back down again and hits the ground. Okay, so it's probably something like that. And to find out the height it is above or away from this starting point, we just fill in the time here, okay? Similar to the other ones. So if I want to find out how far the object is away from this point after 2 seconds, I'll put in 2 for t and it'll tell me how far it is away. Right? So what's the question? After how many seconds is the object momentarily at rest? Okay, well the object is momentarily at rest, remember, up here, when its speed is 0. Or another way of looking at it, at its maximum point. Now whatever way you want to look at it, as looking at it in terms of its speed being 0 or its maximum point, whatever way you look at that, it's to do with speed, so you're going to differentiate that and then you're going to let it equal its speed, which is 0. Okay, that's if you look at it, the speed being 0 method. If you look at it just being a maximum point, well, you're still going to differentiate this and you let it equal 0. So it's the same thing. Okay, so maximum points or minimum points, the speed is always 0. Alright, so the object momentarily comes to a standstill at its maximum point or when its speed is 0. So we differentiate this, so we get dh dt equals 600 minus 10t. We let it equal 0. We solve for t. So t is 6. So after how many seconds, I think, after how many, that says it's meant to be seconds, I don't know what happened there. After how many seconds is the object momentarily at rest? After 6 seconds. So it took the object 6 seconds to get up to this point before it stopped. Oh guys, sorry, mistake, the hell went wrong there? Go back here. It's not 6 seconds, it's actually 60 seconds. Yeah, how did I make that mistake? Sorry, it's me trying to go too fast. I put in minus 10t equals minus 60, but it's not. It's actually minus 600. It's 600 here, not 60. So 600, which will give me 10t equals 600, which will be t equals 60. So it takes 60 seconds for the object to get up to this point. Okay, not 60. Sorry about that. Right, the next thing then, find the greatest height in kilometers the object reaches. Well, so it reaches this point after 60 seconds. Okay, reaches that point after 60 seconds. But so I know after how many seconds it reaches its highest point, but I don't know the actual height. Now, how would I find the actual height? Go back here. Look here. Here's a height formula. It says find its greatest height. I know its greatest height is after 60 seconds. There's the formula to find the height after so many seconds. So if I put 60 in for t, it should give me its greatest height. So 600 t minus 5t squared. And we'll put 60 in then. And when we do that out, we get 18,000 meters. Okay, now be careful, it says in kilometers, so we'll divide by 1,000 and we'll get 18 kilometers. Right, so this object, whatever it is, I know it's a spaceship or whatever, goes up. After 60 seconds, it reaches, is it 18 kilometers away? Although it wouldn't be a very good spaceship because it's going to come back down again after 18 kilometers, right, up in the sky. So I don't know what it is, right? But what we do know is after 60 seconds, it's going up 18 kilometers into the sky, and then it starts dropping down again, whatever this object is. Okay. Right, second last question. A particle P moves in a straight line. After t seconds, the displacement. Displacement is like the distance it was away from the start. So distance. So we can look at it as distance or height or something. Okay, so displacement, distance or height, the same thing. Anyway, after t seconds, the displacement in meters from P, a fixed point, O on the line, is given by this. So basically what they're saying is O is here, and then this object, whatever the hell it is, goes away from O to point P, and after so many seconds then it should come back down. The reason it goes straight up, straight down, Well, we know that because it says it moves in a straight line. If it didn't say it moves in a straight line, well, it could be like this. Okay, could loop to P and then maybe loop back. Or it might even come back at all. Alright, but it does say in a straight line. Okay, so calculate the distance between P and O at the time being 2 seconds. So how far is it away? How far is P away from O at 2 seconds? Well, this formula here gives us the displacement or the distance between the two. So we don't have to differentiate anything, we just put 2 in for that. Put 2 in for T. So S equals, by the way, this S, it's not speed, okay? It's just a coincidence. It's stand for displacement or distance. And we're putting 2 in for T. When we do put 2 in for T, we will get 8, right? And it's meters, so 8 meters. Right, so after 2 seconds, this object is after travelling 8 meters away from where it began. Next question then. The times, it's an S there, so the times at which the velocity of P equals 4 meters per second. Right, we're talking about velocity, which is the same as speed, or rate of change. So we're going to have to differentiate this function to get the velocity or the speed function. So if we differentiate it, we'll get, we'll do it in red, 3t, it's ds dt by the way, equals 3t minus 3t squared minus 4t plus 4. And at the times, so we're looking for the times that the velocity or the speed is 4 meters per second. So don't think, oh, I put 4 in for t. No, I'm looking for the times, I'm looking for t when the speed equals 4. So I will take this speed function. I am looking for the times when the speed equals 4. Okay, so some people might think, oh, that's easy, I'll just put the 4 in for t and find out the speed. No, if you put the 4 in for t, you would be finding out the speed after 4 seconds. That's not what we're asked to do. We're asked to find out at what time is the speed 4 meters per second. Okay, so at what time is the speed at 4? So if we work back here, we simplify this. Take 4 away from both sides. We get that. Okay, we can factorize then. The only thing I can take out is t. We have 3t minus 4 equals 0. Let both of them equal 0 then, so t equals 0 and 3t minus 4 equals 0. So 3t equals 4, so t equals 4 over 3. Okay, so according to this, after whatever this object is, after 0 seconds and after 4 over 3 seconds, its speed is 4 meters per second. Right, okay, that's it. Next question. Okay, last one. A particle moves in a straight line so that its position, s centimeters, not 5, s centimeters, relative to 0, its starting point, at time t seconds, is given by this function. I'll go back over that again. So, a particle moves in a straight line so that its position, s centimeters, relative to O, its starting point. So there's O. And then s centimeters will be whatever distance it is away from it. Okay. After t seconds. Now don't let this confuse you, this t is greater or equal to 0. They might throw that in sometimes. All that means is the time can't be less than 0. Well, that's obvious. We can't rewind time. Okay, so if you see something like that, don't let that confuse you. It just means time has to be more than 0. And obviously time has to be more than 0. We can't have -1 or -2 time. Alright. So here we go. The question we're looking for is, what is its velocity, when is its velocity 0? And what is its acceleration at these points? Okay, so there's two questions in one there. So when is its velocity 0? Velocity is the same as speed. So when? So at what time is its velocity 0? First thing we're going to have to do, we're dealing with speed. We're going to have to differentiate this. So ds dt equals 6t squared minus 10t plus 4. And we're looking for when. So we're looking for a time. So when is its velocity 0 or when is its speed 0? So we're looking for the time, so it'll be 6t squared minus 10t plus 4, and we have to let it equal 0. And we'll work back and try to find t. And using your guide number or the minus b formula or factorizing, you will get t equals 2/3 and t equals 1. Okay, so when is its velocity 0? Well, after 2/3 seconds and after 1 second. And the second part of that question, and what is its acceleration at these points? Okay, we have our speed function. We need our acceleration function. Okay, so how do we do that? Well, we take this and we differentiate it again. Get d squared s over d squared t squared equals 12t minus 10. And again, we'll go back here. What is its acceleration at these points or at these times? So we'll take t equals 2/3. We'll put it in for t. So 12 2/3 minus 10. And that will give us 8 minus 10, and that will give us minus 2. Okay, so there's 1. So at 2/3 seconds, the acceleration is 2. So, or sorry, minus 2. So minus 2 meters per second squared. Second one, we'll put in 1 for t. So 12, 1 minus 10, 12 minus 10, which is 2. So it's 2 meters per second squared. Okay, so there's our two answers. Last part then. When is its acceleration 0? Okay, when? So we're looking for a time. Acceleration 0. Right. We have our acceleration formula. It's here. We want to know what time, so what number do we put in for t to ensure the acceleration is 0. So 12t equals 10. T then equals 10 divided by 12, so t equals 5/6. So the question was, at what time is the object's acceleration 0? Well, after 5/6 seconds, or where t time is 5/6. And the very last part then, and what is its velocity at this time? So what is its velocity after 5/6 seconds? Do we have a formula for velocity? Velocity is the same as speed, so it's this formula. So 6t squared minus 10t plus 4. We want to find out what will the velocity be after this many seconds, 5/6 seconds. So we put 5/6 for t. when we put all that into the calculator, we will get minus 1/6 meters per second. Now, strange, this minus 1/6. Okay, so the minus means it, like, the object must be coming back towards the origin. So watch, if there's the origin and the object shoots away in a straight line, well, that would be a plus speed. If it's coming back, the maths will say it's a minus speed. But that's what the maths is saying, it's a minus speed, right? But realistically, it's not a minus speed. It's just coming back to its origin. So I would be saying it's 1/6 meters per second there. Okay, not minus 1/6 meters per second. You probably get your marks with both, right? But I think that's technically more right. Okay, guys, hope that helped. Okay, good luck.